Lady Ada, what is this?
It's my favorite hour of the week.
Yeah.
It's time for show and tell. Did you know that?
It's I'll tell you, for some days out of the week and even some weeks lately and even some months, this is the most important thing that I think we do.
Yes.
Every single week.
This is my favorite, most important hour of the week. It's the show and tell, where Mr. Lady Ada and me, Lady Ada the engineer, hang out while people from around the world come by and show off their projects, whether it's 3D printing, electronics, cosplay, plants, baking bread, whatever it is that you're making, working on at home, come on by. This is a great place to share and get ideas, and everyone's positive and working together and getting through this. So we're going to start off with Scott. Everybody else will just take 2 or 3 minutes per person. Unmute your mic when we call on you. Scott, take it away.
Hello. As you know, I've been working on the ESP32S2, which is a new chip from Espressif that has native USB. I'm trying to get CircuitPython running on it. I've been streaming every Friday afternoon at 2 p.m. my trials and tribulations, including spilling water on my keyboard when it comes to development. And I hit a milestone today, and I just wanted to show you. So you can see my window here. Hopefully the font's large enough.
Yeah, screen.
And I'm going to do screen.
Okay.
And we get the standard CircuitPython message for auto reload. And if I hit enter, we can now see that we're getting a Adafruit CircuitPython 5.3 on the Saula ESP32S2 prompt. And you can also do math.
Oh my God, I was always wondering, what is 1 + 1? And I was so embarrassed. I didn't want to ask, but you just did it for me.
I totally take that for granted, but I was actually testing this in the last hour. I had like an hour chunk between our hack chat and now to like work on it. And I was like, ooh, I think I'm close. And I actually was like, oh, I got the prompt. It typed in. I was like, oh, I'm totally fine. But I did enter and then it crashed all. Oh, yeah. So there's definitely stuff.
No, you have to have input and output.
Yeah, it was like my stack, like I was getting like the error for like you recurse too much, like you ran out of stack space because I wasn't setting that up right. So yeah, super exciting stuff. The drive doesn't work yet, so that's kind of my next thing to do. And it's very rough code wise, but it's been a way for me to explore and start to understand like all the moving pieces, and then we'll see it like be refined over time. So yeah, if that gets you excited, stop by my stream on 2 p.m. on Fridays at 2 p.m. Pacific, so 5 p.m. Eastern on the Adafruit streams via Restream.
Yeah.
All right. Well, thank you, Scott. And thanks for, showing your work as you go along with these things, because I think that's one of the important things for the community of people that do things with CircuitPython, but also for the engineers out there that are like trying to bring up new chips and doing it like this. We're showing our work. It's code plus community. That's what we've always said, but you can see the incremental steps. And then later on, someone can just look back in time and say, how long did it take you to get to this point? What things did you do? And then, there's like now essentially a finished product that does a lot of interesting stuff.
Yeah, totally. I mean, it's good to stream because if people want to do other ports, now they know kind of the process. Yeah. But I think something that's come up in the stream as well is this idea that like there's no magic to programming. It's a lot of grit. It's a lot of doing things wrong.
Yeah.
And spilling water on your keyboard and like trying for an hour and not getting anywhere, all that sort of stuff. So
yeah, typos that trip you up. I mean, it no matter how many decades of coding you do, it doesn't. I mean, it gets better. You're better at recognizing the mistakes, but you still make them.
Yeah, totally. So hopefully that removes a little bit of the imposter syndrome for folks to watch me like struggle with the simplest things.
There's been a couple younger engineers that said, wow, I saw Lady Ada do something in Eagle, and she said, oh, wow, I just made a mistake. And they said, I've done the same thing, and I was always so scared to even tell anyone because I thought like, oh, it's such a junior mistake, and like it's like no, like we all do that, and it's all lots of iteration. It's all like mistakes, and then adapting, and then iterating, and over and over and over again. So, anyways.
Right. Yeah, we were talking earlier about how I was debugging, and I was like, I'm just print debugging. That's getting me pretty far. So,
all right. Well, you got that serial port. All right. Well, thanks, guys. And don't forget to check in his stream for more
Yeah.
ESP32 S2. It's coming together.
All right, thanks, Scott.
Yeah, progress.
All right.
Next
Unexpected maker.
What are you doing here?
You
Hi,
were
everyone.
expected, and now you're making. What? First, tell us a little about what you do, your company, and then do the show and tell stuff, because you make cool stuff, and I think people should learn about that.
Thanks.
Yes.
Well, hi, everyone. Thanks for having me on. I'm a maker in Melbourne, Australia, and I've got a YouTube channel, which I started out making for YouTube, and now I'm I'm trying to turn into a business, sustainable business, designing and making hardware, and then supporting software and stuff to go with it. Yeah, sorry, I wasn't prepared to do a bit of an intro.
That's you're doing great.
Yeah, I also do streams every Wednesday morning, live streams on all sorts of different things, and I'll be joining Scott's streams every Friday. It's been very cool finally seeing CircuitPython on an ESP32 variant.
Mm-hmm.
I mainly play with the ESP32 space, and so I've not had the ability to work on a project that could run on CircuitPython before, and now I finally can, which is very exciting for me. So, and which leads me into I have been developing two ESP32 S2 boards for quite a while, since September last year when the first beta silicon came out, and I'm happy to announce that my new Feather.
Ooh,
It's not going to focus.
looks cool.
Maybe
You
it'll
can
focus.
see.
Okay, that's
Yeah.
really not.
No, we can see it though.
Yeah.
It's okay.
Here's one with the flashing APA.
Yeah.
So what I decided to do, I've got two boards. I've got my Pro S2, which is a tiny Pico compatible version of it, and now I've got my very first Feather board.
Yay.
It's got 16 meg of flash, 8 meg of RAM. It's got two LDOs on it, one for running the board and a second one for running your peripherals that can be controlled either by the user to turn it on and off or via deep sleep. So if the board goes into deep sleep, it automatically shuts down the second LDO. It's got a stemmer connector on it and obviously all the rest of the Feather requirements.
Great.
And, I actually just pre-released, I've set up a store on my website, unexpectedmaker.com/shop, where people can go on a wait list to get these. I'm making a run of pre-release boards so people can tinker with them, because obviously there's about to be CircuitPython, which is fantastic. There's no MicroPython yet, there's no Arduino yet, and the IDF is still early. It's still in beta, pre-beta for the S2, but there are stacks of folks that want to tinker with the board. So if you want a Feather compatible version of an S2 to play with, it uses the internal USB, but breaks out all of the second, the RTX and TX, so you can do a second USB if you want to.
Great. All right. And where can they get more info about this?
Just unexpectedmaker.com/shop, and you'll see that in there.
Thank
All
you.
right. Thank you so much. And please continue to come back and give us updates and more. This is a big old Feather ecosystem, and we're all doing stuff together. And thanks for making something super cool that people want.
Yeah, this is a great design. I'm super
I see
excited.
some surprise pack as well on the way already to you.
Awesome. Sweet.
All right. Thank you so much.
Thank you. Bye, everyone.
Thank you for coming.
Bye-bye.
Okay, next up, let's go to
JP.
JP. Thanks for waiting patiently.
Hey, JP.
Right on. Hey, guys. So I think last week I showed a little preview of my project that I've been working on, and now I have it in a more attractive form. This is my metronome, and now I made it look kind of like a metronome, too. I've got a little 3D printed stand and case based on a Ruiz Brothers case that I've embedded into this more metronome-y shape. And what we have now, I'm going to actually add a camera. I didn't want to do this before. And
Yeah,
take
add a camera.
Okay.
You
I know, because you
have God powers in this, so I'm going to let you drive for this.
So I got to be careful.
Yeah.
So see a little better here. What I've got are a few controls on the metronome, so we can change the time signature with the left button. So right now I just have 3/4 and 4/4, and we can also change the beats per minute by touching these capacitive touchpads. So we can go up in either increments of 1 and down in increments of 1, or we can go in tens. So now once I've set, oh, you can't see that, sorry, because of the glare. Now you can see that, much bigger number. So I'm at 163 BPM. And then we can start it with this button here, start it and stop it with this button, and it'll beep, and it also flashes the LED on the back, which if I put my hand back here, you'll be able to see that.
Let's go for it. Oh, I like how it keeps the time with a different tone.
Yeah, so you get a little accent note, and you can set that in code. There wasn't I didn't want to add too many things to the UI, so you're not changing things like accent codes or eighth notes or sixteenths, but all that is going to be fairly easy to change inside of code. And since you couldn't probably see it before, I'll do this again. If I touch the 0 cap pad, you'll see it changes from 1s to 10s. So that's the value. So now if I'm in 10s, I can go down.
Okay.
Something much slower, and then I can switch to 1s and get
a good use of all the different inputs on the CLUE, because there's only 2 buttons, so you have to use the capacitive touch pads. But I like how you use the screen to indicate the function of the buttons and the capacitive touch pads. That's cool. Thank you. Yeah, this has been a fun project, a really interesting one, and now my daughter, who practices piano, will have something better than her janky mechanical one, which just it was not keeping even time. Yeah, it was always sort of this sloppy time. So all right, cool. Yeah. Okay, no excuse not to practice. That's right. Yeah. So I'll be working on a different project. I'm wrapping this one up, writing a guide on it now, but I got a different project I'll be showing on my live stream tomorrow. And a hint is it will involve this. I'm enlightened, or I will be when I watch your show. Yeah, so come on by. That's at 1 o'clock Pacific and 4 o'clock Eastern, and we'll be building stuff. So come on by.
Thank you, JP. See you tomorrow. And see some of your videos tonight on Ask an Engineer.
Super. Thank you.
Okay.
Next up, we're going to go to Melissa. Hello, Melissa.
Hi. Okay, I got a couple of things to show.
Yeah, what you making?
First of all, let me just do this since I only have this on this camera here.
Whoa.
Okay, I got this set up here.
Good work.
And I was using that to write I2C bitbang protocol for the Python, or for the Raspberry Pi.
Yeah.
And there's just too many things to hold up all at once here.
Yeah.
But so I went ahead with the logic analyzer and just kind of like mapped it out and stuff. I kind of started out looking at a few different code examples, but they weren't exactly all helpful. So I finally got it working this morning, and I got that all submitted. And the other thing I wanted to show is I have this great fat one here, which I have been adding Blinka support for.
Yay.
So it has,
they're cool.
It has 2 40-pin headers and then a bonus 20 pins. So it has 100 pins. And so that'll give a lot of GPIOs. It has a lot of other goodies like ADC, digital analog converter.
This is like a super ultra powered FT232H.
Exactly.
It's like you're like, oh, I like the FT232H. It's great for, Python to GPIO. But what if I need to control 100 LEDs?
Exactly.
I'm
not sure if it's 100 GPIOs because it probably has some voltage and.
All right, 80.
Yeah, it'll probably do that.
Okay. All right, well, it's awesome. Thank you, Melissa. And it's exciting to see every week there are new boards added to Blinka support for CircuitPython, so people can run our 200 CircuitPython libraries on everything from the $5 Linux boards to great FETs to host adapters, everything. We're taking over the world. All right, thank you.
And I think a lot of community members for contributing some of the board additions too.
I know, it's awesome.
Yeah, one of the goals I hope that someone takes on is there's a lot of things that run Linux, and there's a lot of things Blinka could be on, or it is and we don't know about it. Tesla cars, you could put Blinka on. There's a lot of neat things that are out there that are Linux embedded power. So if anyone has this really interesting Linux device or something that's powered by Linux and you want to get lots of hardware working with it, do it with Blinka and then give us a pull request.
That's right.
All right.
Yeah, and there's also a couple learn guides now for how to add boards to the platform.
I think that helped a lot. I think people are following your guides and they're like, oh, and then you review it and they're like, these are great. That's all the tests. Okay, cool. Thanks, Melissa.
Thank you.
Thank you.
All right.
Next up is Erin. Hello, Erin. What you got going on this week?
Hello. I've got a CLUE project to show off this week also. I made a vertical garden It's right back here. It's a little bit hard to see, but I wanted to show it in person because it's just, I mean, it smells nice and it feels nice, and it's made of just moss that I found in the backyard.
I like how this is like an outside simulator. It's like, are you indoors a lot, but you want to put your feet on grass? You get one of these. You can just put your feet on it.
Exactly, and it's got a superpower too. It actually, I'm going to go ahead and share my screen here so we can get some close-ups. But it has a little clue board right here in the middle. And what that's doing is it's using the temperature sensor or the humidity sensor, or you can set it up however you'd like, the barometric pressure sensor to get weather data from the air, and then it's actually mapping the data to the different neopixels that are around the outside edge. This thing is upcycled just from an old shoji screen that I had that broke, and so we built a little frame for it and put the neopixels in there, and then got the clue to actually map the data to the different areas. So current data is showing kind of in the middle here, and then our old data is here, and 2 hours old data is here. Basically, what it means is that you can look at this and you can see what the pressure, the temperature has been doing over the last couple of hours, and see whether it's rising or falling or whatever. And a little graphic that shows up, a little hot air balloon if the pressure's rising, or a little submarine if the pressure's falling.
Yeah, and that tells you. Yeah, it's like when you're on watching the news and the weather person's always like, we have a low pressure system moving in. That's when you know it's going to rain, or high pressure means it's going to blow away the rain and it's going to be sunny. So it's it's not the same as having the internet connected weather, but that'll be kind of nice to see. People could see how the barometric pressure changes over the week in their homes.
I have it set up with temperature right now so that I can demo it a little. So I'm just going to shoot some canned air and see if it'll change colors back here.
What is it going to be? It's kind of bluish.
Yeah, it's blue is kind of high pressure. I get temperature right now.
If you turn the canned air upside down, it could be like Mr. Freeze, and you can make the come out. But I don't know if that's a good idea.
Yeah, I don't know.
It might be a bad idea. Maybe don't do it.
All right, looks great. Thanks, Erin.
Yeah. Anyways, I don't know if I'm going to be able to get it to change colors today for you guys, but it looks just beautiful. And
well, the video has it all, so we can
just launched a tutorial on the Learn system. If you're interested, the moss is all preserved and everything too, so you don't have to water it. I mean, it's really cool.
We will have the video on tonight's show.
Awesome.
Great,
Thanks so much, Erin.
Thank you.
All right. Next up is Anne. Hello, Anne. What do you want to show off this week?
Well, as you know, I help Lemoore get a lot of guides done, and learning electronics is really cool with all the guides, but Lemoore wasn't doing this last century. Well, I'm sorry, before 2000. Let's not be. How did we do it back then?
I am limitless. I have lived 5,000 years.
You are eternal.
I think so.
Last century, we would go to the Radio Shack store for everything. And one thing the young experimenter would do is get, if they had a little money, these were not inexpensive, are these kits where it had the components mounted. There's no breadboard necessarily. They were all on springs. And they had a project book with 200 different projects. And this was the Radio Shack learning system, basically in paper. So I thought I'd show off this.
Okay, so you have one. Is this from when you were younger, or you just found this recently?
No, I got the receipt. I bought this 20 years ago in 2000 from a Radio Shack store. And I think I just wanted to play with it, or a little bit of nostalgia too. But I didn't get to it over much. But that's when I got into Arduino and started working with you all. So it's got a little front panel where you can access some controls. And then on the inside, it has components. And instead of the breadboard things, they have these little springs. They're all springs. And you put the wires into the springs, and you'd connect your components together.
Yeah.
And they wasn't very smart. You can see there's two logic circuits here, and you can
no Arduino, no microcontroller. It's a 555 and a couple op amps, and good luck.
Basically, you can make a radio. They had a nice little thing, and then they did things like input and output transformers and stuff.
I know we don't really do that anymore. I think people got like.
So flashing an LED for them was using a transistor. I
Yeah.
thought that was kind of cool. So that's how it was done before, but rather than doing all of that, we can just go to the learning system, and Adafruit's got all this great stuff, a little bit of Python code, and you're doing a lot more than Radio Shack could ever do.
All right.
All right, thank you so much, Anne. And for all the folks that subscribe to the Python on Hardware newsletter, hug report, and thank you to Anne, who's been leading that up while Lamore and I are doing double duty. We're doing meetings with governments and cities and all that to help out with the COVID crisis. And then at night and our staggered shifts, we're at the factory. So we can't get to everything, but the team has been so helpful. So thank you, Anne, for getting the newsletter out. Subscribe on adafruitdaily.com.
Definitely.
All right, thank you. All right, Phil B, what you got blinking this week?
Hi, let's see. I came by last week with like a handful of parts, but they're all like mounted on a stick. And there is a guide for this now. It's a light painter, so you take long exposure photos with this.
It also looks like you're trying to clean my screen.
Yeah.
Yeah.
There's anyway, using the CLUE board and Circuit Python and a .star strip, and the pictures it makes don't look like your typical, VIC-20 graphics light painting. It does these really nice continuous tone images, and the photos I was able to take for the guide don't really showcase that too well because I was working solo, because of situations. So there's some nice pictures in the guide, but it can do a lot better than that. Also, I mean, seeing how fast CircuitPython can refresh the .star strip.
Yeah, these are two that you sent me. I'm like, hey, can you make these? So the only thing I'll say is like, these are really good. You can, you can't really tell that you're doing light painting. It's like, oh, like, look, it's just like a, camera.
Yeah,
a phone.
there's some scan lines in there, but it's not your usual blocky graphic.
Yeah, they're really nice.
Yeah, but anyway, playing with it and seeing how fast it is, I think we can probably do persistence of vision stuff too, where you don't need a camera. You just whip this around super fast and you get pictures. Maybe that's the next project. I don't know.
All right.
Photography for now. That's where it starts.
All right, we'll show off that guide. I think the photos look great. And yeah, this is taking code that we wrote for a Raspberry Pi computer and bringing it to a microcontroller. So it's easier. It's got a screen on it. You can even preview and have a UI, and you don't need to whole Raspberry Pi Linux setup. It's just some code. So I thought it was neat that the NRF52840 and CircuitPython was powerful enough to do this. I
was, let's say, skeptical. I didn't think we'd get there, and no, it's totally doable, and I'm kind of excited by that.
All right. Well, thank you for washing my windows with rainbows.
Sure thing.
All right. Thank you, Phil B. We'll show some of those photos and more tonight. Next up, let's go to Noe Pedro.
Hey, what's up, folks?
How you doing? Are you settled into your new place? It looks like you are.
Yeah,
Almost.
It's going pretty good. Just got to sell the other house, which we're under contract, so we're doing pretty good. Yay!
All right, good work.
Shout out Lady Ada for suggesting this project. This week we made a 3D printed mount, kind of a clampy bit for the PlayStation 4 DualShock controller. So we wanted to make it so that it has a tripod screw. So it's got that right there. And we wanted to be able to adjust the viewing angle. So we thought, hey, GoPro has a really good mounting system. Let's 3D print that. So we did. And
are you using a using a GoPro mount, or are you just making an adapter for their mount?
Yeah, it's its own adapter for a GoPro mount. So you're using the GoPro screw because they just have this nice knob.
Yeah, no, it's really nice.
You could just use an M5 screw and a hex nut, but I like the little. I have so many of these GoPro screws laying around, so I figured let's put those to use.
Great.
Yeah, so I wasn't actually aware of this either. JP mentioned it to me earlier. That since it's a Bluetooth controller, it doesn't just work with the Xbox. I have it paired with my my mobile phone here, and it's a really nice controller. So playing games like this,
I don't like it when there's like the ones that snap on. It never works.
This is a really good idea because if you play a lot of video games with that controller, you'd probably want to keep using that controller.
The controllers are so good. I mean, I think the significant cost of the console is getting these like really high quality and they don't break,
Yeah.
the buttons don't jam, you know, you
Yeah.
don't get it. The joysticks, they're magnetic, they're not potentiometers.
You know, on a side note, you know, they say that we use our phones so much, it's more than we blink. We do it like 50 times an hour, if not more.
Yeah.
It's interesting that the game controllers, when they're used, they're probably one of the most used pieces of technology, mechanical technology that moves, that like just lasts.
There's nothing more ergonomic and durable than a game controller.
Interesting.
They should teach mechanical and electrical engineering classes just on a controller. Like
All right.
it's like there's years of knowledge.
I like I know
in
it's
them.
like beating this game while we're just like
Okay.
blabbering. Okay,
All
anyways.
right, so cool.
What's going on?
So okay, great. So you can use it with anything. It's Bluetooth.
Right.
Thank you for not
Yeah.
surprising.
And we didn't even get to talk about our displays, but yeah, they have the tripod screw like built into the case, which I love. That's the best thing to do. So if you're ever designing something, you know, consider a tripod screw.
You love those quarter 20s. They're great. They're inexpensive. And yeah, once you have that in, and you've done a bunch of guides on how to 3D print with one of the nuts inside.
Yeah.
I think we stock them even.
Yes, we do. It's got a D-ring, so it's pretty easy to just kind of, I don't need a screwdriver. I just take the D-ring out, and now I can unscrew this bit.
They really, another, old but extremely good quality way to attach things in an adjustable manner. Love it.
Cool. So check it out. The files are up there. Step files and things are all online.
Yeah.
All right. Thank you so much. We will be playing some of your videos and more. And then one last bit of thanks and shout outs. Thank you for printing all of the 3D brackets for the face shields. Those were our bridge ones that we used between.
We gave away hundreds.
We had to make thousands of the foam ones that could be like dunked in bleach, and that went to a lot of the hospitals you hear about in the news. And then in between, because there was a material shortage, we were still getting those, no pun intended, very surgically to the places that needed them. We were doing no contact handoffs to doctors at Adafruit. They would show up and they would have them ready for them right there, hop back in their car and keep going. And thanks for doing that. I'm so happy we don't need to do those now because they have enough, and it looks like there's stockpiles that are forming. We're going to have enough in case things happen. But thank you for turning your entire printing farm into something that was so helpful when we needed in New York. So thank you.
Oh, excellent. Thank you.
I hope we never print those again.
We have more just in case, though.
Yeah.
back to printing Yodas. Okay.
All right.
Thanks, guys.
Thank you.
Bye-bye. Okay, next up, Liz,
Hey,
and
Liz.
Liz's screen.
And her musical stylings.
Hey, how's it going?
Is this a music project?
This is actually a slight sideway from that. My printer had some problems, so Noe's kind enough to mail me the mounts we need to keep going with the solenoid project. So there will hopefully be more next week on that. But this is actually a Bluetooth project that I'm also working with Noe and Pedro on, where it's going to alert you with I always forget the name of this tiny little motor, haptic motor. When you get notifications on your phone, or also to stand up and move around. So I'm going to demo it by sending a text to my phone real quick.
Okay.
So
Live demo.
yeah, sent the text. There we go.
Whoa.
Nice.
And then the light's going to blink.
Oh, that's
And it'll
cool.
stay on. And when I get rid of the notification, it turns off.
Cool.
So the idea of this is like if you have to be paying attention to your phone from work from home, but maybe you don't want to have your phone like attached to you, you can have this near you, and when you get a notification, then you'll know, okay, I have to go check my phone. And also to remind you to stand up and walk around, because I'm using the what's it called? The Bluetooth current time part of the library to be able to tap into when it's on the hour to go off then too.
That's cool. One of the things that's neat about haptics and the way that you did this is it's an assistive technology device already.
Yes.
So let's say if you have some hearing issues, you still get the lights and you still get the vibration, and you can still get the same notifications. So designing things like this means that everybody can use it, and it's useful in all sorts of different ways. Good work.
Definitely. Yeah. Thank you. Yeah.
Thank you, Liz. Awesome.
Thanks,
All right, 2
Liz.
fun projects coming soon.
All right. Next up.
Hey, guys.
Hey,
Can you hear me all right?
And yeah.
Hey.
What's going on?
Yeah, I got a couple of things I wanted to show off. First, I just wanted to mention I started using StreamYard because of these show and tells, and it has been awesome. I've got a bunch of different people that are using the same account with me.
Yeah.
And so that's what I've
Those
printed
are the things that work.
I've had to be battle tested. So when we said, okay, Hangouts is over, well, when Google said Hangouts is over, I'm like, I need to find something. And as soon as I found something, I'm like, this is so good. I need to tell everybody. You can bring communities together with this.
Oh yeah, it's been wonderful, and I wanted to be able to do a couple of different things like switching video and stuff. So I actually have Minicam running to feed my virtual webcam in,
Okay.
so I can switch between all my work stuff. And so I found this cool 3D Minicam, Minicam Studio,
Okay.
and there's this awesome 3D printer file on Thingiverse for a Waveshare 7-inch monitor. So that's just kind of what I've got going over here, so I can do all my touch controls. But what I wanted to show today mainly is this. So I published this blog post to the AWS blog. This is a Adafruit pyportal in one of the 3D printed case designs. But it's periodically pulling down images from the latest images from the Curiosity rover and then overlaying it with weather data from the InSight Mars lander. So on there, it's got the average temperature, wind speed, and pressure, as well as the Martian sol and season. And so that's all CircuitPython running on the device. And then here I wanted to pull up the code real quick. Okay, so here's the, it's actually using a Lambda function. So there's just like a serverless function running in the cloud as an endpoint. And the CircuitPython pings this, and this does all the heavy lifting, like going through all the rover images, finding when's the last time there was available photos. Since they don't post them current every day, it's probably like every other day that you'll find new images. Finds those, picks a random one, resizes it, uploads it to an S3 storage bucket, and then provides that URL to the CircuitPython, to the pyportal, as well as like the InSight weather data. Mm-hmm. And I'm using the display IO library to do all the displaying on it. Shout out to Brent Rubel for helping me figure out a issue with making requests that have timeouts. So that was a huge help. And so all this is published on the blog. All the code's open source on GitHub. And then
that's awesome.
Yeah, and then one more thing. It's not really a project yet, but I ordered way too many of these little micro DC air pumps. They're meant for, I guess, water tanks. And I just got a Elegoo Mars resin printer that I've had some success with. So I'm going to try to print little compressor tanks for them so that they can like pop in. And then I have it coming in the mail, like micro solenoid valves. So I can try to make like a small self-contained air compressor with the tank and a release valve for projects yet to be determined.
Cool.
Right on.
So, yeah.
If you want, come into Discord, tell people about your streams that you're doing. You can also send me an email. I like to let the StreamYard people know about like what we're doing. They were super nice when they first got started, and I said, hey, here's some things that like would really make this work out for us. So definitely also, if you're on Twitter, at them and let them know like, hey, this is working out. They're a small team and they're doing amazing work, bringing a lot of people together. And this is something that when we started looking at the tool and talking to people, and then when COVID started to happen, the Open Hardware Summit, they needed to go from a physical event to a virtual, and they used StreamYard too, and it really worked out well.
Oh yeah, it's been amazing. We've done so far, like we did a local music festival that went virtual. We did it all on StreamYard. There's a weekly Arizona history, LGBT history happy hour. And then there's like, we're doing quarantine.today. So awesome stuff. And thank you guys for everything you're doing and especially all the CircuitPython stuff. It's been, I spent so much time in Python, and I never thought in my life that I would be this into Python now.
Yeah.
It's super fun, isn't it? I think it's so much fun to write code in CircuitPython. Like me personally, I just think it's so enjoyable to never think about pointers.
Yeah. It's
With Circuit Python, if you come in with a Python background, you can do so much in hardware, and it's like these little encapsulated universes that you can do so much with, and it's like this standalone Python device. So cool that you can take all that knowledge and then it just kind of transfers to all these different platforms now.
Oh yeah, and it's been a lot of fun, especially with doing the stuff on serverless with the function. It's running Python 3.7 in the cloud, so I just switching back and forth between two flavors of Python, and it's cool. It's weird writing documentation on it. I have to like remind myself and label things like this was Circuit Python, this was in the cloud.
Which flavor is this snake?
Thanks, Moheeb. That's awesome
If
project.
when we're back to sending out stickers, just let me know and I'll make sure you get a sticker.
All
Awesome.
right.
Back to Planet.
All right. Next up and last up is going to be Mark. Mark, play us out.
Hey, Mark.
All right, no pressure.
Yeah.
So a couple things. One is the 3D case I made for the Cricket powered robot
Cool.
that I have just finally got printed and together. But this led me into a much deeper rabbit hole in that I was trying to make it drive straight, which turns out to be a much harder problem than I thought of at first. And then when I started reading research online, I see that I'm not the only one. So eventually it led me to accelerometer, magnometer, gyroscript 3 9 DOF chip, and I've got the LSM 9DS1 in here now. And then I realized that you can't use it on CircuitPython. It was all for Arduino. And I'm fairly new to Python. I've been coding for quite a while. So I decided to try to do my first port of something written in C over to CircuitPython.
Yay.
And so now I have the Mahoney attitude and heading reference system algorithm working in CircuitPython. I wasn't even sure if it would run fast enough. This is running on a Feather M4.
Yeah.
So I was able to get 300 samples a second, tune that down to about 100. And if I can share my screen. I have got your rabbit demo if you guys can see this.
What I love about rabbit demo is this like the hardest part of doing sensor fusion is like, well, how do I show what it looks like? Turns out it's actually just getting the stupid processing script working. We just ported it to web serial. It works okay. You can't go too fast with it, but it seems like it's working fine.
Yeah, it's a great way to tell that I actually had success with this, and it's all running in CircuitPython now.
That's so awesome. Well, it's actually running in pure Python?
This is running in pure Python.
Wow, that's amazing. I actually am surprised that worked.
To be honest, I was too. I was really excited last night when I actually saw it working.
Okay, cool. Well,
you get a sticker when we're shipping stickers.
Then you get a sticker, and then in our Discord, for CircuitPython, post up, and we'll help you get a library written up for this because we have one of the things that we did was all of our sensors have the same interface API. So you should be able to pass in any magnetometer, accelerometer, and gyroscope, and it will, be able to get the data and fuse it. It's one of the cool things about Python is, types don't really exist in the same way. So you can kind of pass whatever you want. And as long as it has the interface, it's happy.
Yeah, that would be great. I've got it sitting on GitHub right now, but with a big warning at the start that this is my first real Python project. So
no, that's cool. I mean, I also think this is neat because it's like there's a couple different algorithms and just going through it. They actually start to learn a little bit what is it doing? What is the proportional part or integral or derivative, whatever? Like, how is it actually doing this? And you can learn how to tweak the values so you can minimize magnetic effects, which you're going to get with those motors, which is something you got to watch out for.
Yeah, I've been working on that a little bit too. Yeah, it's been really interesting, and I've been reading a lot of research papers the last couple of days.
Okay. Another thing you might want to check out is somebody recently did a pull request for Count.io, which is encoder counting. And that's another way to do motor control is you just count how many times the wheel is spinning. And then you just, if one falls behind, you just speed it up, or, you know what I mean? Like you just keep track of how many counts and you just make those counts even, and then it drives straight.
Yeah, I was trying that a little bit, and actually the sensors aren't, I don't know if you guys can see it. It's just hidden in here. But it was working, but not as much as even just the gyroscope on its own.
All right,
So,
cool. Well, whatever you got working is great.
Thanks a lot.
All right, that's awesome.
Thank you so much, Mark.
Nice work, Mark.
Okay, that's our show until tonight. Thank you so much, everybody. We're here every single week, 7 p.m. to 8 p.m. Wednesday nights. And we extended it from 7:30 to 8, so it's a full hour every single week. Thank you, everyone, for joining us. It's our favorite special come-together time each week. So we'll see you on Show and Tell.
Yes.
We have all the other shows. Be sure to check youtube.com/Adafruit. You'll be able to see all those shows. I'm also going to show this cute dog. That dog is sleeping.
I can't tell. You can't tell if it's a photo or a live video.
It's a flying dog.
Okay, but I can't prove that the dog's in a photo. Oh wait, no, that's
hello. Yeah, hi.
Okay,
hi,
treats.
Park. Let's go to the park. So that's your moment of cute doggo.
Okay.
So thank you, everybody. We'll see you next week. And Ask an Engineer starts in 10 minutes.
All right, thanks, everybody.